Chapter 3. Experimental Techniques. This chapter can be divided into two distinct sections. The first portion provides an overview of the experimental methodology used in the synthesis of nanoparticles, NPs. The second part of this chapter describes the various characterization methods that are used to determine and understand the properties of the synthesized nanoparticles, NPs. 3.1. Synthesis of nanoparticles. There are two approaches for the synthesis of nanoparticles, i.e., top-down approach and bottom-up approach. Figure, top-down approach and bottom-up approach. Top-down approach. The top-down approach is the synthesis nanoparticles by reducing larger materials down to the smaller sizes. This method starts with bulk materials and then uses various techniques to break them down into smaller sizes until reaching the nanoscale. Bottom-up approach. The bottom-up approach is the building or assembling of nanoparticles from very small size particles, atomic or molecular constituents, gradually forming larger structures. This method starts at the atomic or molecular level and involves controlled chemical reactions or self-assembly processes to produce nanoparticles. Sol-Gel method is the bottom-up approach for the synthesis of nanoparticles. In the process of synthesizing nanoparticles, various methods are available. Each method has both advantages and limitations. Some of the available methods for the synthesis of nanoparticles are: Figure, synthesis methods. 3.1.1, Ball milling method. The ball milling technique is a top-down synthesis technique to synthesize nanomaterials. Ball milling is a grinding method that grinds materials into extremely fine powders. The ball milling method consists of balls and a mill chamber, and overall a ball mill contains a stainless steel container and many small iron, hardened steel, flint pebbles, silicon carbide, or tungsten carbide balls are made to rotate inside a mill drum.